Alright, algebra students, this is the solution set video presentation for graphing linear inequalities. This is something that we started learning last week, and now we have an assignment where you have to take a linear inequality and then either graph it or pick the correct graph. We're also going to be finding the slope and the y-intercept. A couple things about these videos. If you are the sort of person who wants things to move faster, download the YouTube app on your phone and you can change the speed at which this video plays. Or if you're viewing this on a computer, you can right-click the settings icon in the bottom right of the YouTube video screen, and you can also adjust the play speed. But I'm going to speak at a very measured, slow pace for those students who need to have things explained in a very measured way. So, another couple of preamble matters. I realize not everyone has a $150 graphing calculator just sitting around the house like this. So while I will show how to solve these problems using a graphing calculator, I will not require that you use one. Okay, so we will look at how to solve this using a graphing calculator, but all you need to do this homework assignment is a pencil, maybe a pencil sharpener, and a straight edge. Beyond that, if you want to get some map colors or otherwise use some other materials, that's fine. You really don't need anything beyond this and your brain. So with all that in mind, let's start. Let's take this first one. Y is less than 5/3 x minus 4. Y is less than 5/3 x minus 4. Well, we could put this into the Inequalities program on the calculator, or we could just look at it for a second. Remember, this is in the slope-intercept form of the equation of a line, but instead of an equal sign, there's an inequality sign. So, we can gather some data right off the inequality. For example, what is the slope of this inequality? Well, it's a positive number. It's an improper fraction. It's 5/3, because this is y less than mx plus b. So y less than 5/3 x minus 4 means that m is 5/3 and the y-intercept, or b, is -4. I'm going to write these answers in using a Sharpie because I think it'll show up better on the video. So this m is 5/3 and the y-intercept is -4. So here's what I'm trying to tell you. You don't need a fancy calculator to use this data that you just gathered to find the correct answer. So what we're hunting for is an inequality graph that has a y-intercept at -4. So x equals 0, y equals -4, -4, and a slope of 5/3. That's going to be positive. So, just a couple things to keep in mind as we go through this. I'm going to open up this nifty toy right here. This is a protractor with an arm on it. You don't need this, but I want to show you something kind of neat. Okay, let me put this protractor with this cool little arm on it right over that first graph right there. A slope of 1 will have an angle of exactly 45 degrees. If the slope is 1, the angle will be 45 degrees. Okay? So just to kind of draw that in, that's about right there. That's a 45-degree line. Okay? That line right there. That would be if m equaled 1. So I'm trying to give you a little bit of intuition here. M doesn't equal 1 though. The slope, or m, is bigger than 1, because in this case 1 would be 3/3. So 4/3, 5/3. So it's bigger than 1. And when the slope is bigger than 1, the angle of the slope gets steeper, like that. So it would be steeper. So we're looking for a slope that's steeper than a slope of 1. Alright, so we're looking for a slope that's like that. Now I only show, you don't need this. I just show it so you can remember a slope of 1 is 45 degrees. So if the slope is bigger than 1 and it's a positive number, alright, it's going to be somewhere up here in this range. If the slope is still a positive number slope but is less than 1, then it's the angle is going to be between 0 and 45, somewhere in this range. So I'll keep bringing this toy thing back into our discussion so we can develop some intuition about what we're looking for. So we got a slope bigger than 1. Therefore, I'm looking for a line that is steeper than this little test line that I drew for 45 degrees. So I'm also looking for a y-intercept of -4. So let's take a look at answer choice A. Right? Oh, there's one more thing we're looking for. So notice that in this problem, our inequality sign is less than. Not less than or equal to, less than. So that means we need to be looking for a dashed line. So now we have 3 things to look for. A steeper slope than 1, a y-intercept of -4, and because it's a less than symbol, a dashed line. So let's go hunting for our answer. Okay, on this first A here, I have a y-intercept at -4. Okay, y-intercept at -4 right there. It is steeper than 1. See, it's steeper. It's a bigger angle, if you think about it that way. So maybe that's a possibility. All right, maybe. So A is a maybe. Let's go on to B. We can eliminate B. So B's got a y-intercept of -4, but it shows a negative slope. And we saw that our slope was 5/3, a positive number. So this is a negative slope, downward sloping line. We're only interested in upward sloping lines, so we can eliminate B. It's not B. How about C? Right? Now we can eliminate C for a couple of reasons. We can eliminate C because the y-intercept is not at -4. It's somewhere a little bit below the -2 marker, right there. So just on that alone we can eliminate. It's actually crossing at x equals 4. They're trying to play a game with you. So, but here's another way that you can eliminate C as an answer. let's get our protractor back. I said 45 degrees was the slope of 1. Okay, well, look at this slope. This slope is not as steep as a slope of 1. So this slope is down here. And we already said that our slope was bigger than 1. So we know we're looking for a slope on our line that is between, 45 and 90, somewhere in there. But here on the problem C, we find, let's try to match it up. We find a slope of about 33 degrees. Okay? Well, 33 is less than 45, so just on that intuition, that visual intuition, we can throw out C. But here's another reason we can throw out C. It says here that y is less than 5/3 x minus 4. So what I'm looking for is a solution where the shading is underneath the line. All right? Here the shading is above the line. So because the shading is above the line, because the slope is not steep enough, and because the y-intercept is not -4, we can eliminate C. Now let's look at D. All right. So far I've got a dashed line. It's good. I've got a y-intercept at -4. That's good. My slope is steeper than my test line at 45 degrees. That's good. So really, these are possibilities. A and D are possibilities. How do we choose between A and D? Well, let's go back to this symbol, less than symbol. That means I'm looking for shading below the dotted line. Well, down here in D, I have shading above the dotted line. So D can't be right. Even if we never knew and we didn't have a calculator, okay, have y'all noticed something? We haven't actually done any computation. It's all just visual analysis. We don't have a calculator. All we have is our heads. We can eliminate B, C, and D just based on mathematical intuition alone, leaving A. And in fact, A is the correct answer. The shading is below the line. We have a dashed line. We have a y-intercept at -4. And we have an angle of our slope that is in line with our hypothesis about the slope being steep at 5/3. So now let's check it, because I could be wrong. So remember, when we're going to start doing computations, always clear the memory, because who knows what nonsense is in there. And then to do this inequality stuff, click on Apps, and then if you're using one of the orange calculators, you'll have to go down to 0, but on this model it's 6 for inequals. Okay, that starts that up. It's going to take you to the y equals. Make sure that you change the symbol that you want to use to the correct symbol. So in my case, I want to use a less than symbol. Go down to OK. That changes the symbol of the equal sign to an inequality symbol of less than. And now I just put in what I see, 5/3 x minus 4. Now, I know that you guys know how to do a fraction, but this is how I learned how to put in a fraction. So you can actually put in the fraction if you want, but this is how I learned it. I do an open parentheses, 5 divided by 3, close parentheses, x minus 4. That's really the same thing as doing 5/3. If you know how to do it as a fraction, good for you. But this is how I learned how to do it on the older calculators. And now basically we just want to graph it. Right? Let's see if we're right. So what we're looking for is a graph that looks just like that. Now we already solved the problem in our head. Now let's see if we're right. Drum roll. Wow. Neat. So we are right. We are right. And if I hit the trace button on my calculator, it'll take me to the y-intercept at y equals -4, just confirming what we thought. Okay? So 1 is A. I'll move through number 2 more quickly since now we've got the process. What is the slope of this inequality? Well, the slope is, if we read the inequality, it says y is less than or equal to -5x minus 2. So the slope of this inequality is -5. What is the y-intercept of this inequality? Well, remember the inequality is in y less than or equal to mx plus b format, so the b factor here at the end is -2. Remember to carry that sign. So I'm hunting for a very steep negative slope. Remember, a slope of 1 is 45 degrees. So a slope of -1 would be like -45 degrees. Okay? So if I do it this way, we're looking for a negative slope, and that is -45 degrees off the horizontal. -45 degrees down there. That's for a slope of 1. Okay? So if a slope is -5, it's going to be extremely steep, negative steep. So we're kind of looking for an extremely steep negative number, or negative downward pointing line for our slope. And we're looking for a y-intercept of -2. Okay, with that in mind, let's go hunting. Oh, so here's another thing. This is a less than or equal to sign. So we are looking for a solid line. What can we eliminate right away? Well, this is a dashed line. This is a dashed line. And this is a dashed line. Happy days, it only leaves us B. But, you know, because we're trying to learn something here and it's not merely about getting the right answer, let's kind of walk through the thought process here. Why is this wrong? Well, it's a dashed line, so that's definitely a problem. But it's also wrong because the y-intercept here is at 2, not -2. Okay, the slope is about right. It's pretty steep. But the y-intercept is at 2, so I know that's wrong. It's shaded correctly, but it doesn't have a solid line, and the slope, or the y-intercept of the inequality line, needs to be at -2. Let's skip down to C. What's wrong here? Now see, they're playing games with you again. They graphed this with an x-intercept of 2. Remember, we're looking for a y-intercept of -2. Again, our mathematical intuition can kick in and say, we already hypothesized that our slope was going to be really steep and negative. Well, this slope is about right there. So off the horizontal, not very far. So this would be a slope of less than 1 on the negative side. And we're looking for a slope of -5. Way, really steep line down there. Okay? So we can eliminate C for those reasons. We don't have a y-intercept that's correct, and our slope is all wrong. But we could also eliminate it the way we eliminated the first time, because this is a dashed line instead of a solid line. How about D? Okay, D can be eliminated because the y-intercept is at 2, not -2. So they're checking to see if you carried that negative symbol. It is also a dashed line, and plot twist, is this a positive or negative slope right here? That's a positive slope. So this one is playing a game where it's making sure you are paying attention to the sign in front of the slope. Remember, a slope of 1 is 45 degrees off the horizontal. 45 degrees. So a slope of -5 would be extremely steep as a negative number. Okay, down below the horizontal. Down here. Well, this one is extremely steep above the horizontal. It's way up here. I bet you that's a slope of +5. Okay, so we can eliminate D for all those reasons. Plus, it doesn't have a solid line, which leaves us with B. I should have circled A here and then B here. B is the correct answer for number 2. Now, I hope you guys are starting to kind of get these. Let's look at number 3. Y is greater than 1/2 x minus 4. Okay, let's notice a couple of things right away. Let's get Mr. Protractor back out. Remember, I said that the slope of 1 would give us a line that was about 45 degrees, like that. And a slope of greater than 1 would put us in this territory here. And a slope of less than 1 would put us somewhere down here. Now just use your mind for a minute. If a slope of 1 puts us at 45 degrees and a slope of 0 puts us down here, what is a slope of 1/2 going to put us at? If your thought process is to say, well, somewhere about exactly halfway between 0 and 45, then you're correct. Okay? So that would be 22.5. About 21, 22, about right in there. Okay? Halfway between 0 and 45 degrees. So what we're looking for here is a positive slope of 1/2, 0.5 or 1/2. Let's write that in. Positive slope, okay, so above the horizontal, and a y-intercept, or B, y-intercept of -4. Again, with these two pieces of information and a quick check of our inequality symbol, we can solve all these problems. Now that's a greater than sign. It's not greater than or equals to, it's greater than. So we're looking for a dashed line. Might be able to eliminate some if they're solid lines. Maybe not. So we got our little our thought processes together, and let's go looking at the answers. So because it's a greater than symbol, we're looking for shading above the dotted line. Can we eliminate any of these answers based on that alone? Okay, shading above the line, shading above the line, shading above the line, shading below the line. Okay, so D is not going to work. Eliminate D. All right, now the problem has gotten easier. We only have 3 to choose from. Now we're looking at the y-intercept. Okay, that's our next thing. The y-intercept is negative 4. So do any of these have a y-intercept that's not negative 4? Okay, A is negative 4, B is negative 4. C is positive 4, playing a game with you to check to see if you carried that sign. So just based on that alone, we can eliminate C. Now we're down to A and B. Things are heating up. Okay, this is the final round between A and B. Which is it going to be, A or B? Well, we have to ask ourselves a question. Does this inequality have a positive slope or a negative slope? That's a positive number, positive 0.5 or positive 1/2. So what we don't want is a downward sloping line, because that would indicate a negative slope. So just based on that intuition, I've now eliminated 3 of the 4 answers, leaving A. Well, let's check to make sure that A is right. Is A shaded above a dotted line? Yes. Does A have a y-intercept at negative 4? Yes. Does the slope of A indicate a positive slope that's about halfway between 0 and a slope of 1, around 22.5? As a matter of fact, it does. Okay? So for all those reasons, my final answer is A. But let's check it on the calculator. Go back to y equals and change my inequality symbol to be greater than. Now plot 1/2 x minus 4. All right, that looks pretty close. Different scale of the window. Let me show you something. If I put the window scale to be exactly the same as this window scale, it might look identical. So this is on the x values, the window scale. You guys might not have seen this too much. X min, look at your graph, is negative 6. What's x max? 6. Okay, the y min is negative 6, and the y max is 6. Okay, so now let me regraph with these new window configurations. I bet this will look exactly the same. I don't know, what do you think? I kind of liked it better when there was more visibility. Put it back to negative 10 to 10, negative 10 to 10. Okay? Anyway, that just confirms that A is correct. And we'll move on to number 4. Y is less than or equal to x minus 1. All right, so our inequality symbol is less than or equal to, which means we're looking for a solid line. And the slope of this linear inequality is just 1, because there's no number in front of the x, so that indicates a slope of 1. Positive 1. What is the y-intercept? Just look at the numbers here. Negative 1 is the y-intercept. Okay, so what we're looking for is, because it's less than or equal to, we're looking for a solid line where the shading is below the line we're looking for a positive slope of 1 with a y-intercept of -1. Mr. Protractor comes back out, and we're actually going to try to find a slope that exactly matches our 45-degree angle, because the slope is 1. You guys might be noticing that some of these slopes are 1. Okay, so let's go through our deductive reasoning here. Let's look at A. Does A have a solid line? No. Does A have a positive slope? No. Does A have a y-intercept at -1? Yes. Yeah, well, too bad. It failed all the other tests. Is it shaded below the line? Yes. But it doesn't have a solid line, and it's a negative slope, and we have a positive slope, so it's not A. Sorry, A. How about B? Is B shaded below the line? No. Okay, so right away I can move on. Does B have a y-intercept at -1? Yes. Does B have a slope of 1? I don't know. You tell me. 45 degrees. And looks to be exactly 1. So yes, it has a slope of 1, but it's not a solid line, and the shading is above the line, not below the line. So too bad for you, B. We're going to move on. How about C? Is the y-intercept at -1? No. Is the shading below the line? No. Well, this isn't looking good for C. Is the line solid or dotted? It's dotted. I'm looking for a solid line. You know, for all those reasons, I'm sorry, C, you're out. Well, just by process of elimination, we're at choice D. Let's now analyze this to make sure D fits with all of our premonitions. Okay, does D have a positive slope of 1? Looks to be so. Okay, right in there you can see the line showing through the little hole in the protractor. Does D have a solid line? Yes. Does D have a y-intercept at -1? Yes. Is D shaded below the line? Yes. So solid line, y-intercept -1, shaded below the line, slope of 1, everything looks good. We're calling it for D here. But, you know, to check in with the math god here, the calculator, and let's go in here and clear out our existing plot, change our inequality symbol to less than or equal to, and type in our equation x minus 1. Graph that. Let's compare it to D. Yep, they look pretty close. So calculator verifies what we already knew from mathematical intuition. Fantastic. So far we're getting 100 on this. I'm excited. Let's move on to number 5. Number 5, x is greater than 1. Or sorry, x is greater than or equal to 1. So this is a little bit of a horse of a different color here. So x is greater than or equal to 1. Couple things. We're looking for a solid line. But this is not, ladies and gentlemen, this is not a y equals mx plus b type of equation. This is an x equals something type of equation. So what do I mean by that? All equations that just have an x and there's no y value anywhere are going to be perfectly vertical lines. Guaranteed. All right? I'm going to prove it to you. If I go in here and change this inequality symbol back to an equals, so it's basically not an inequality anymore, and I just put in like 1 billion x, and I graph it, I don't know if you can see that. It made a perfectly vertical line right through the y-axis. Okay, so the calculator has a hard time dealing with those x equals because the calculator is in y equals. But in our inequality thing, we can actually switch to x equals. So did you see what I did there? I went up and highlighted x equals and switched from y to x. So just to test this, I'm not going to do this on the calculator just yet, but let's see what x equals 5 looks like. Let's graph that. You see it's a perfectly vertical line at 5. Let me go back here and change this to x equals. I'm going to put a bunch of these in. X equals 5, x equals 6, x equals 1, x equals 2, x equals 9, x equals 8, and just graph them all. You see all those perfectly vertical lines? That's what x graphs look like. They're perfectly vertical lines. So let me go back here and clear all that out. Clear, 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 clear. And we're going to put Mr. Calculator away for a minute. Okay, so now that we know we're looking for a perfectly vertical line, we can eliminate 2 of these. This is a diagonal line, so bye-bye, B. And this is a perfectly horizontal line. Well, that indicates that there's no x factor and it's just a y equals type graph. So it can't be that since there's no y factor. So it's either going to be A or D. We're already at a 50-50. So what is the slope? Well, it's basically infinite. You know, it's extremely big. Well, don't worry too much about this for now. And there is no y-intercept, so don't worry too much about that for now. What we're really looking for on these types of problems is the x-intercept. Where does this thing cross the x-axis? Well, it tells you. It crosses the x-axis at x equals, or x greater than or equal to 1. So the x-intercept here equals 1. Let's go hunting, guys. So we have an x-intercept of 1 for A and an x-intercept of 1 for D. So it's going to come down, both of them are solid lines. This is a greater than or equal to symbol. With greater than or equal to symbols, and you have a perfectly vertical line, which side of that vertical line should be shaded for greater than or equal to? Well, my intuition is telling me that maybe this should be shaded to the right, but maybe we don't know, okay? So my intuition is telling me it should be shaded to the right. Everything to the right. So I think the answer is D, because over here all the values are less than or equal to x equals 1. They're less than or equal to that. So this is a greater than or equal to sign, so I think the answer is D. So I'm going to circle D and say x is wrong. But let's check the calculator, you know. And I don't have an answer key for these in front of me, so I could be wrong. So remember, I went and set my plot. You know, this is how it usually looks. Y equals. Well, I'm going to go set my plot to x equals so I can plot those x values. And I'll change my inequality to greater than or equal to. And then just put in 1. and graph it. Bingo. So our intuition was right. It's D. Cool. Number 6. Y is greater than 7/5 x plus 4. Okay, so now we're kind of back in the saddle with our normal linear inequality graphs. So we have a positive slope. What is the slope? It's 7/5. Okay, positive 7/5. 7 over 5. 5 over 5 would be 1. So this is bigger than 1. Now, if 1 has a slope of 45 degrees and the slope is bigger than 1, we're looking for a steeper slope, something up in there, in that kind of territory. That's our intuition. What we're definitely not looking for is a negative slope. Okay, so if the line goes down to the right like that, we know it's wrong. Finally, we have a greater than symbol, so we're looking for a dashed line. Because it's a greater than symbol, we're looking for shading above the line. Okay, so we're looking for shading above a dashed line. Let's go through our answers and see if we can eliminate any just before we find the y-intercept. Let's see, all the shading looks to be above the lines. This is above the line, this is above the line, above the line, above the line. They're all dashed. Okay. Can we eliminate anything based on the slope being positive? Are there any negative slopes plotted? Yes, there are. That's a downward sloping negative line. Okay, A. It's not A. This is a downward sloping line, so it's not B. We have a positive slope of 7 over 5. So we've already eliminated 2. We haven't even found the y-intercept yet. What's the y-intercept? Well, it's right there, positive 4. So the y-intercept is 4. See, I'm getting it from right there. So let's find a y-intercept of 4. That's 4 on the y-axis, positive 4. And we want shading above the line, dashed line, and a slope slightly greater than 45 degrees. Okay, slightly greater than 1. Okay, so it's really between C and D. Is my y-intercept on D positive 4? No. It actually looks like negative 3 to me. So it's not D. They're playing games with you again because what they did was they put an x-intercept at 4, positive 4. But that's not what it said. It said the y-intercept was 4. So again, these little problems play games with you. But you can play games right back. Now look at C. Is it a dashed line? Yes. Because it's greater than, we want shading above the line. Is the shading above the line? Yes. Is the y-intercept at 4? Yes. Does the slope seem to indicate that it's slightly greater than 45 degrees? Well, you tell me. Here's 45 degrees. So is that slope slightly greater than that? Well, I've got to, in order to make this go in my protractor, I've got to increase my slope angle. So yeah, C has got a slope of greater than 45 degrees or greater than 1. So yeah, I've got a slightly steeper slope. It's looking good. I'm going to call it for C. Final answer. Let's check the calculator. Turn it on. Go back to y equals. And I think I need to turn off this, clear out this x equals stuff. Make sure you got the y values there. And change your inequality sign to greater than. Okay. And now put in 7/5 x plus 4. 7/5 x plus 4. Okay. And what we're looking for is something that looks like C. Let's see the magic happen. graph. Yay! So we have a positive y-intercept shading above the line, and it's a dashed line. Is our y-intercept at 4? Trace. Y equals 4. It's hard to see right there. X equals 0, y equals 4. Cool. So 6 is C. Flip the page. Uh-oh. I see a nightmare coming on the right side of the page, but let's do number 7 real quick. Y is greater than or equal to 2x minus 2. So greater than or equal to means we're looking for a solid line. 2x minus 2. What's the slope? The slope is 2. Minus 2, or negative 2, is the y-intercept. So let's use our intuition. Greater than or equal to, I'm looking for a solid line, and I'm looking for shading above the line. Y-intercept at negative 2. So below the x-axis. Y-intercept at negative 2. And my slope is going to be twice as steep as a slope of 1. So here's a slope of 1. So I'm looking for a pretty steep slope. Something up there like that. It's for a slope of 2. Because slope of 1 is 45 degrees off the horizontal. So I'm looking for a steeper slope. Okay? So with that in mind, let's go hunting. A. Is the slope, is the y-intercept at negative 2? No. The y-intercept is at positive 2. So is the line solid or dashed? We're looking for a solid line. It's dashed. Is the shading above the line? Yes. Is the slope steeper than a slope of 1? Okay. A slope of 1. Remember, if you ever want to know what a slope of 1 is, just do that. Put a line straight through the problem. That's slope of 1. Yes, it's steeper, but it's a dashed line. The y-intercept is wrong. They put a 2 instead of a negative 2, so it's not A. How about B? Is the line solid? Yes. Is the shading above the line? Yes. Is the y-intercept at negative 2? Yes. Is the slope steeper than a slope of 1? Yes, it is. Okay, so B is a possibility. I'm starting to like B. B sounds good. Now let's go down to C. Let's just make sure, C, dashed line, y-intercept is positive. We have a slope that is actually less steep than a slope of 1. So, for all those reasons, this thing is not going to work. And how about D? Well, D is easy to eliminate because D has a negative slope. This is a downward sloping line. Okay? So that indicates a negative slope. It's a dashed line, guys. It has a y-intercept at negative 2, but it's a dashed line. We were looking for a solid line. And the shading is below the line, so that's not right. So this is not D. So, just again, by process of elimination, I've arrived at my final answer of B. But let's check with the calculator. Go back to edit this, clear that out, and change my inequality symbol to greater than or equal to. Okay, go to OK. And then put in 2x minus 2. And what I'm looking for is a graph that looks just like B. And there we go. So just to trace this, I find that If I hit trace, my y-intercept is indeed at -2. That's fantastic. And it looks kind of like B. It's shaded above the line. There's a solid line there. So I'm fairly confident that it's B. And indeed it is B. All right. Now we're going to move on to something that everybody's going to look at and say, what? Okay. Couple things. Remember that the slope-intercept form of a line for an equals sign is y equals mx plus b. That's the slope-intercept form of the line. This is a great form of the line because we can just read the slope and the y-intercept right off the equation. Makes life very simple. This is in y equals mx plus b format. We could just read the slope as 2. We can read the y-intercept as -2. But over here, it's not in that format. It's in what's called standard form. 2x plus 5y less than -5. So this form, the standard form, is ax plus by equals c. Okay, so it's a bit more complicated. Now c becomes the y-intercept, and there can be values in front of y and x. So I'm seeing in my mind a bunch of heads collectively exploding. But let's just work through this thing, okay? Because it's not as hard as you think, and the first time you do this successfully, you will feel like a genius. And you will feel completely competent to solve these problems. All right, so we have 2x plus 5y less than -5. So remember, our symbol is less than. We're going to be looking for a dashed line. And because it's less than, we're looking for shading below a line. So before we start to solve this thing, let's take a look at our answers and see if we can eliminate any of them. Can we eliminate A? Dashed line shaded below the line. Can't eliminate A. How about B? Dashed line shaded below the line. Can't eliminate B. How about C? Dashed line shading above the line. So I don't know what I'm doing, but I can eliminate C because the shading is above the line. Or can I? We don't know. Okay? You can't rush to judgment with these problems. The reason you can't rush to judgment with these problems is because you have to do some algebraic manipulation of these problems before you are absolutely certain what the inequality symbol actually is. All right? So we've got to slow down. You know, there's an old song that says, slow down, you're moving too fast. You got to make the moments last. All right? It's called Feelin' Groovy. It's a good song. So we actually cannot make that intuitive leap before we do our algebraic manipulation. So I guess we're going to have to do some algebraic manipulation. Let's write this down. 2x plus 5y is less than -5. All right? What am I trying to do here? Maybe that would be a good place to start. Here's what I'm trying to do. Get y alone on the left side. That is what I am trying to accomplish. Get y alone on the left side. Well, right now, y has a little buddy named 2x, and he's camping out with a partner named 5. So we're going to have to get all that stuff on this side of the equation. Now remember, with inequalities, if we multiply or divide by a negative number, we have to flip the sign. So keep that in mind as we go. So I'm just going to rewrite this again. 2x plus 5y less than negative 5. Let's begin. Well, I want to get y by itself. So first let's take out the 2x. Let's subtract 2x on both sides of the inequality sign. So I end up with 5y less than negative 2x minus 5. Do you see how I did that? I put the negative 2x in front because what I'm trying to do is I'm trying to turn this form of the equation into this form of the equation. Now what do I do? Well, 5 is multiplied by y. So if I've got something multiplied by something, in order to get rid of it, I've got to divide both sides by 5. So divide the left side by 5, and I have to divide, this is important, I have to divide the entire right side by 5. Okay. The inequality sign doesn't flip because these are all, we did a subtraction up here, which doesn't matter, and over here we did a division by a positive number, which again doesn't make the sign change. So now on the left side this cancels out, and we have y is less than negative 2 over 5x minus 5 over 5. I just split this 5 to go sit underneath both parts of the equation. Okay? Now here's the good news. We just do one more simplification. 5 divided by 5 is 1. So we can reduce that down and say y is less than negative 2/5 x minus 1. So there is our slope-intercept form. And we can actually find, if we go down here to my solutions area, we did find the slope-intercept form. See? Now, what is the slope in our slope-intercept form? Well, if we look over here, it's negative 2/5. So just write that down here under m, negative 2/5. And what about the y-intercept? Well, the y-intercept is negative 1. So just put negative 1. Well, now we're feeling very comfortable, guys, because now that we've gotten to this form of the line, we can go ahead and proceed normally. We have an inequality symbol here, so we know we're looking for a dashed line. It's a less than sign, so we're looking for shading below the line. We have a negative slope, negative 2/5. Let's get out Mr. Trusty protractor. So there is the slope. Okay, so that's a slope of 0, and here's a slope of negative 1. Okay, so negative 5/5 would be a slope of negative 1. Well, negative 2/5 is less than that, so it's going to be something in here, in this region here, between 0 and 1. Negative, between 0 and negative 1. So the slope's going to be like that. I keep doing this with the protractor so you develop a mental visual picture in your mind of what you're looking for. So we're looking for a downward sloping line that is shallower than this angle. So something in this region here. Okay. Can we eliminate any of these problems? We're looking for a downward sloping line, and here's an upward sloping line. Okay. Is the y-intercept on C -1? No, it's a +1. So it's an upward sloping line. That upward sloping means positive slope. Well, we have a negative slope, -2/5, and the y-intercept is positive. So, plus the shading is above the line, guys. This thing fails on all counts. It's not C. Well, let's go back to the drawing board. So here, A, do we have a downward sloping line? Yes. Is it dashed because it's a less than symbol? Yes. Is the y-intercept for this at -1? Yes. Is the shading below the line? Yes. So now it's an issue of looking at the slope. Is the slope correct? Well, this is where all of our work with Mr. Protractor comes in handy. Remember, a -1 slope would be just the opposite of a +1 slope, and we said a +1 slope was 45 degrees. So a -1 slope, I'm just going to flip this thing down, would be -45 degrees. And we said that our slope was -2/5, which is less than 1. So we're looking for a shallower slope. All right? Now, if we didn't have this fancy protractor with us, we could just draw in a slope of 1. Think about rise over run, okay? Rise over run. We're going to do a negative slope, though. So down 1, okay, over 1. Down 1, over 1. Down 1, over 1. Rise over run. So a negative slope of -1 would give us that line right there. So without having to do any computation, I know that the slope of this has an m is -1. -1. But we said that our slope was shallower because it was -2/5. So it wasn't all the way to -1. That leaves us with B or D. Let's continue. So does B have a slope that is less steep on the negative side than a slope of -1? Yes. Is the y-intercept at -1? No. The y-intercept is at +1. So we can eliminate B. So now, again, without doing too much work, we have eliminated A, B, and C. That means it's got to be D, right? But let's check. It's a negative, it's a less than symbol. So is it a dashed line? Yes. Is the y-intercept at -1? Yes. Is the slope shallower than a slope of -1, which would be this? Well, actually, it would be exactly this. Is the slope shallower? Yeah, it is. It's shallower. It's flatter. Think about a mountain. This is a steep mountain here, slope of -1. This is a flatter mountain. Okay? So, yeah, it's flatter. Is the y-intercept at -1? Yes. Is the shading below the line? Yes. So I'm pretty certain that just by visual analysis, I have a perfectly coherent curve with respect to these values here. But let's check. Let's check with our calculator. Let's go clear this out and change my inequality sign to less than, and then put in our mx plus b form of the line is negative 2/5 x minus 1. So what I'm going to do, you might have a different way of doing this. In order to type this in, I'm going to hit this open parentheses symbol and then type negative symbol, negative 2 divided by 5, close parentheses, and that gives me negative 2/5. Okay, now I know many of you have the knowledge to put in a fraction, but you don't really need to. This will work just fine. Negative 2/5 x minus 1. Minus 1. Okay, use the minus sign for minus 1 there. Now let's just graph it. And look at that. Neat. So it matches the graph that is shown here. Does it have a y-intercept at negative 1? Well, if we click the trace button, yes, it shows y equals negative 1. So y-intercept at negative 1. So that validates all of our hypotheses, and we can circle D. So again, with and without a calculator, these problems are completely doable. Flip the page. Oh boy, more fun. So what these problems are asking us to do is just get the equation in y equals mx plus b form, or the inequality in y equals mx plus b form, then find the slope in the y-intercept, and then do our basic analysis. All right? So here's how we walk through these problems. Let's take our first problem over here. I'm going to write it down here. So let's transfer 5x minus y less than or equal to 0. So 5x minus y less than or equal to 0. So our task is to get y by itself. I don't want a minus sign by it. I don't want 5x by it. I want to get all that stuff on the right side of the inequality. And remember, if we multiply or divide by a negative number, we're going to have to flip this sign, this inequality symbol. So let's start. First, I'm going to move the 5x over. So minus 5x on both sides. Minus 5x, minus 5x. And that leaves me, this goes away, that leaves me with minus y less than or equal to minus 5x. All right, now, this is confusing. It says negative y less than or equal to negative 5x. How do I get rid of the negative sign? Well, one way to help visualize how to do this is to remember that that negative sign is really a negative 1. Okay? Negative 1 times y less than or equal to negative 5 times x. Okay, so that negative sign can go away. If I think of it as a negative 1, negative 1 times y. If I want to, if something is multiplied by something and I want to get it by itself, I have to divide it out. So I'm going to divide negative 1y by, you guessed it, negative 1. And I'll divide the entire right side of the inequality by -1. Okay, remember I tripped the wire just there. I divided by a negative number. Uh-oh, that means I have to flip my sign. So now what I'm left with is y is, flip the sign, so less than or equal to, the opposite of less than or equal to is greater than or equal to -5 over -1 x. Well, two minuses cancel out. Minus over a minus cancels out. So let me just rewrite this. Y is greater than or equal to 5 over 1x. And 5 divided by 1 is just 5. So for simplicity's sake, I'm looking for y is greater than or equal to 5x. Okay? So let's do our analysis. Our analysis tells us that the slope, because this is in y equals mx plus b form, so the slope, m, is 5. So m equals, I should write it up here first, y greater than or equal to 5x. So m equals positive 5. What about b? Where's b? What happened to b? You know, plus b, where'd he go? Well, there is no b value, so we can assume that it's 0. b is 0, okay? So it's like 0 when it's not there. So b equals 0. The y-intercept is 0, 0. Now that's just one of those things you kind of have to get used to. So what we're looking for is an extremely steep. So that's a slope. That's a slope of 0. A slope of 1 is about 45 degrees, like that. So a slope of 5 is going to be extremely steep, almost vertical, kind of like that, a little bit off the vertical. It is a greater than or equal to sign that we're dealing with. So we're looking for a solid line. Let's go through our possible answer choices and eliminate all of those that have dashed lines. So, and we'll look at y while we do it. Does this have a y-intercept of, let's look at C. Does this have a y-intercept of 0? Yes, it does. In fact, all of them do. When the y-intercept is 0, okay, when y-int is 0, that passes through the origin. It's going to pass through the origin because it's 0, 0. And they all do that. They don't give us any wiggle room there. But let's look at C. Okay, first of all, it's a dashed line, so we know that it's not right. Is it now greater than or equal to means that we're going to be shading above the line. So dashed line already cancels it out. It's going through the origin, though. We have a positive slope of 5, but this is a downward pointing line, so that's a negative slope. And it's shaded below the line, not above the line. So for those reasons, C's out. Okay. Now let's go to D. Again, we have a downward sloping line. It's below the horizontal, like that. So it's a negative slope. And it passes through the origin. Greater than or equal to, we're looking for a solid line. This is a dashed line. Greater than or equal to, we're looking for shading above the line. This is shading below the line. Therefore, it's not D. Now let's go back up to our two real possible choices, A and B. All right. Let's look at A. Does A pass through the origin at 0, 0? Sure does. So the y-intercept here, remember, was 0. And the A graph passes through 0. Is it a positive slope? Well, yes, it is. As a matter of fact, it's positive, sort of, a little bit. Guaranteed to be positive. We might have something to say about that here in a minute. But is it shaded above the line for greater than or equal to? Yes, it is. It's shaded above the line. Is it a solid line? Because it's greater than or equal to, we're looking for a solid line. Yes, it's a solid line. So maybe it's A, right? Well, let's look at B. Does B pass through y-intercept of 0? Yes. Is B a solid line? Yes. Is the slope positive? Really positive. Okay? Really positive. Yes. And remember, is it shaded above the line? Well, yes, it is. It's shaded above the line. So, here's my dilemma. It's either A or B. Now, how am I going to resolve this without a calculator? Well, here's how I'm going to resolve it. I use my mental image of the angle of a line. Okay, so remember, a slope of 1 is 45-degree line. So a slope of between 0 and 1 would be in here. Now, what was my slope? My slope was 5. So, I'm looking for an extremely positive line up here close to 90. A slope of greater than 0 but less than 1 would put me in this territory here. So let's look at A. Here's the slope of 1, and my slope that I'm given is way down here. Okay? Way down here. So this is not going to work because this slope is less than 1. Okay, it's a very shallow hill, and I'm looking for a really steep hill to get my slope of 5. So I'm going to eliminate A based on that. So my slope here, everything checks out about this graph, and the slope is extremely steep. Plus, I've eliminated all the other answer choices, so I'm going to go with B for number 9. Now we can check it with the calculator. And we will do that right now. Here's the calculator, and we'll clear out our existing plot, change our inequality sign to greater than or equal to, and just to switch things up, we will change the color to green. Okay, and let's plot this line. 5x is the line that we're plotting. There's my slope-intercept 5x. So we'll plot y is greater than or equal to 5x. Let's graph. What we're looking for is something that looks a lot like B. Graph. Wow. Cool. Do we have the y-intercept at 0? Hit trace. Yes. X equals 0, y equals 0. It's an extremely vertical line, steep line. Just so you can compare, I keep talking about this. Let's plot a slope of 1 in there so you can see the difference. See that slope? That's a slope of 1. Okay, so this is much more vertical than 1. The answer is definitively B for number 9. How about number 10? Very exciting. Number 10. 7x plus 2y is greater than or equal to 10. So what we have to do here, ladies and gentlemen, is we have to solve that standard form and turn it into a slope-intercept form. So let's rewrite it down here. 7x plus 2y greater than or equal to 10. Okay? So remember our rules about dividing and multiplying by negative numbers, and let's proceed. So remember, I want to get y by itself. So my first task is to subtract 7x from both sides. That leaves 2y greater than or equal to negative 7x plus 10. Now, why is it plus 10? Well, that was a positive 10 right there. There was no negative sign. And I'm going to put those x values, I'm always going to put them up in front because I'm trying to find that y equals mx plus b form. So I'm on my way. Now I just have 2y to get rid of the 2. I'm going to divide both the left and the right side by 2. All right. So that leaves me with, I don't have to do a sign change or anything. Y is greater than or equal to, and remember, I'm going to split this 2 up to go under both terms. Y is greater than or equal to negative 7 over 2x plus 10 over 2. And 10 divided by 2 can be simplified. 10 divided by 2 is 5, right? So I say y is greater than or equal to negative 7 over 2x plus 5. And I'll write that up here. The slope-intercept inequality for this line is y greater than or equal to negative 7 over 2x plus 5. So let's take a look at what we're dealing with. If this is in y equals mx plus b form, and I say that it is, what is my slope? Well, it's negative 7 halves, or negative 7 over 2. So my slope is a negative number, negative 7 over 2. Okay? And what is the y-intercept? The y-intercept is positive 5. So just put a 5 there. Now, taking a look at negative 7 over 2, what does this really equal? Like, because I want to get an idea in my head for my protractor work of, and we know it's going to be a negative slope, but how negative? It's going to be down here, or is it going to be up here, or is it going to be over here? Well, what would be a negative slope of negative 1 in terms of 2? Well, that would be negative 2 over 2. But that's not what we have. We have negative 7 over 2. So this is an improper fraction. That means that I'm going to be dealing with a negative number that's bigger than 1. Right? How many times can 2 go into 7? Let's see. 2 times 2 is 4. 2 times 3 is 6. So it can go into 7 3 times, and then there's a half left over. So the slope here, negative 7 halves, is really negative 3.5, right? So a slope of negative 3.5 is going to be steeper. This is going to be a downhill line. There's negative 1, okay? But I've got negative 3.5, so that's going to be somewhere in this area here, okay? Somewhere more steep than a slope of negative 1. Somewhere in here. So if I see a line that is in this range, that isn't going to work. If I see one that is exactly negative 1, that's not going to work. It needs to be steeper. Negative 7 halves, steeper slope. Okay, so we now have the equation, the inequality in slope-intercept form, which means we can kind of proceed here. What is our inequality symbol? Well, it's greater than or equal to. So I'm looking for a solid line. And it's greater than or equal to, so I'm looking for shading above the line. And I am looking for a y-intercept of 5. Okay, y-intercept of 5, positive 5. So let's just start at the top. A. Do we have a y-intercept of 5? Yes. Do we have shading above the line? No. Is it a solid line? No. So this is not a greater than or equal to sign. This is a less than sign, right? So does this have a negative slope? Yes. Does it appear to be more negative than a -1? Yes, it does. And yes, it appears to be steeper. Negative, more steep. But because it's a dashed line, I can't do anything with it. And the shading is below the line. The shading should have been above the line. So A, I'm really sorry to do this to you, but you're out. Now you guys can already see that just based on that greater than or equal to symbol, we could have eliminated A, C, and D just because those are all dashed lines. But let's go ahead and consider C. C, is the y-intercept at 5? No, it's right there. See, they're playing a game here. The x-intercept is at 5. So that's not going to work. Plus the shading is below the line when the shading should have been above the line. The slope, guys, we were looking for a negative slope that was extremely steep, like the marker, if it'll stay still, like that. But look at this. We got this wimpy slope here that's just like that. So this can't be right. It's not C. Now D, again, dashed line, shading below the line. And the y-intercept is not 5, but it's -5. So that's just, guys, in every way possible, it's wrong, except for the fact that the slope is a very steep negative angle. So that's, but still, for all those other reasons, it's wrong. So again, by process of elimination, we've come down to the final answer of B. But let's give it its full analysis. Do we have +5 for the y-intercept? Yes, we do. Do we have an extremely steep negative line, a negative slope? Yes, we do. Is it shaded above the line because of greater than or equal to? Yes, it is. Is it a solid line? Yes, it is. So for all those reasons, I'm going to go with B. Now let's check B in the calculator to see if it is in fact correct. So we got greater than or equal to symbol. And what I'm going to do to put in, I bet it's easier for me to just show the whole calculator. I'm going to do open parentheses -7 divided by 2 close parentheses x plus 5. And then I'm going to graph it. And I see that the graph is indeed matches B. So the graph matches B. So that shows us that the answer is correct. So we'll put this aside and we will proceed. We're almost done because we skipped 11 through 16, so now we're on number 17. So we're faced again with our old foe, a problem where it's not in mx plus b form. We're going to have to solve this thing. All right, so let's go down here and write this again, x plus 2y greater than -2. So that we want to get y by itself. Okay, so let's first subtract x from both sides. And that leaves us with 2y greater than -x minus 2. Okay? Well, I want to get the y by itself, so I'm going to divide both the left and the right side of the inequality by 2. And that cancels out the 2 on the left side, leaving me y greater than, remember I'm going to put this 2 term underneath both those numbers, negative, we'll look at this, negative x over 2 minus 2 over 2. Now, some people look at this and they're confused. What is negative x over 2? How am I going to get that to look like y equals mx plus b? Well, just remember that negative x over 2 is the same thing as negative 1 over 2 times x. So I can actually write this y greater than negative 1 over 2 x minus, 2 divided by 2, guys, that's 1. So minus 1. Therefore, my slope-intercept inequality is y greater than negative 1/2 x minus 1. Since we have this in slope-intercept form, the question I have for you is, what is the slope? And you will say, well, it's negative 1/2. Negative 1/2. All right? And what is the y-intercept? Ladies and gentlemen, if we look at the problem, it's right there. There's the b factor. It's negative 1. Negative 1. So, we have our inequality symbol at as greater than. So we're looking for a dashed line. And we want greater than, so we want shading above the line. What else do we want? We want a y-intercept at negative 1. And we want a slope that is negative, but if this is a slope of negative 1, okay, we want a slope that is exactly half that distance. Negative 22.5 degrees would give us negative 1/2 on the slope. So we're looking for a shallower slope than a full-blown negative 1. We want it to be down here, negative 22.5 degrees off the horizontal. So we're looking for a negative slope that kind of looks like that. Okay, we'll put that aside and we'll start to do our analysis. Let's look at A. Does A have a slope of negative 0.5, negative 1/2? Well, maybe, I don't know, it kind of looks like it. So, does it have a y-intercept of negative 1? Yes, it does. Is it a dashed line? Yes, it is. All right, is the shading above the line or below the line? The shading is below the line. Sorry, A, you had your chance and you failed. So you're not right. How about B? Does B have a y-intercept of negative 1? No, it has a y-intercept of negative 2. Is the shading above the line? No, the shading is below the line. So, plus the slope is steep. The slope of minus 1 would be like that. But look at this slope is way steeper. So for those reasons, B is wrong. Let's look at C. Is the y-intercept negative 1? No. The y-intercept is 1. They're playing games with you. It's a downward sloping line. Is the shading above the line or below the line? Well, it's below the line. So, wow, this isn't looking good. Is the angle of the slope appear to be about halfway between this and perfectly horizontal? Yeah, it does. So the slope looks right, but the shading is wrong and the y-intercept is wrong. So C is wrong. Again, guys, we've seen this several times now. By process of elimination, we've arrived at our answer, but let's do the analysis. For D, is the y-intercept negative 1? Yes. Is the shading above the line or below the line? The shading is above the line. It's a greater than sign, so we're looking for shading above the line because it's greater than. So far so good. Does this slope appear to be shallower than a slope of -1? It does appear to be shallower. It's shallower. So for all those reasons, I'm going to vote yes on D and say that D is the answer. But let's check our graphing calculator. Okay, so this time I have to change my symbol to just greater than, and we'll change the color to orange, okay, Panther orange, and then we'll go in here and plot it. Remember, do -1 divided by 2 in parentheses, x minus 1, and then graph that. Okay, I've got shading above the line. Do I have a y-intercept at -1? Yes, I do. It looks like the picture here for D, so it is in fact correct. D is correct. Fantastic. Okay, now we have number 18. Number 18 is actually telling us to graph this thing ourselves. So, we're actually going to have to draw something. Well, thankfully this is already in y equals mx plus b form, that slope-intercept form, and you see our m is given as 2/3, which I wrote here, and our y-intercept is given at 2, which I wrote there. So here's how we're going to graph this thing ourselves. Dun, dun, dun. This is fun because what you need to graph this is just a straight edge and a pencil. All right. So what we're going to do is we start at our y-intercept. So we go over here to 0, 0, and we go up to 2. Now before you put pencil to paper, look at your inequality sign. This is greater than or equal to. So here's the thing. When you plot points using an inequality notation, you need to pay attention to this sign. So we're looking for a solid line, and because we're going to be plotting points, we're looking for closed-in points on that line because it's greater than or equal to. So we don't want an open circle, and we don't want a dashed line. We want a closed circle and a solid line. So with that in mind, let's start our journey. You start your journey at the y-intercept. So you start at the y-intercept and plot that point. 2. Okay, 0, 2. Now you say, well, how do I draw the next point? I don't know what the next point is. Well, just remember that slope equals rise over run. Okay, so we have a slope of positive 2/3. Well, that's just rise is 2. How about it this way? The rise is 2 and the run is 3. So we're just going to go up 2 over 3. All right? So it's a 2/3 slope. Here's what I'm going to do. I'm going to go up 1, up 2. Now to the right 3. 1, 2, 3. And I'm going to plot that point. I'm going to plot another point. Up 2 over 3. Right there. And I could do this in reverse, by the way. I could go down 2 over 3. Right there. Okay. And I could do it again. Down 2 over 3. And I have all those points. Do you guys see a pattern emerging here? It's starting to look like a straight line. Well, in fact, it is. So let me go ahead. Because it's a greater than or equal to symbol, I'm going to draw in a solid line instead of a dashed line. This is fun for people that like to draw, because you can really do kind of a little bit of art here. Now, this is where the art comes in, by the way. Is this a greater than or equal to sign? So do I want to shade above the line or below the line? Well, I want to shade above the line. So I want to shade above the line. So in this case, I want to shade in the region above this line. So this is where, if you like to draw, you get to draw. You get to draw. And I don't want to ruin all the lead on that one. So I'm going to use this. I'm going to do this. I'll use this highlighter thing to shade over here above the line. Okay, so we just shade this all in here above the line. And then we've done our inequality, right? But let's check it. Let's make sure it's right. The way you check these is actually easier than, but in a very similar fashion to the way we did it before. So we're going to put our inequality symbol in as greater than or equal to. So change it here, greater than or equal to. And let's change the circle, change the color. I can put it on navy, which kind of looks like this purple color. And go to OK. And then graph it. Oh, wait, sorry, hang on. Mistake. Go back to y equals. Got to clear out what I had typed in there before and put in my current inequality. So let me just put this in correctly. That would be 2/3 x plus 2. Okay, now graph that. There we go. Okay, so you see we can create, using no technology whatsoever, just the brains in our heads, we can create a nice graph that looks exactly like what this $150 calculator was able to do. And I think that should make you feel good that you can do that. All right, so 18 is also correct. Let's do 19. See, now it's all graphing now. Uh-oh. Well, good news, it's going to get easy. I mean, now we're starting to get really good with this stuff. Let's take a look at number 19. Y is less than 1. Right? So is this in y equals mx plus b form? Yes. It is. It doesn't look like it, but it really is. So here's what we're given. When you see y is less than 1, and there's no x in the inequality, that means that there is no slope. So the slope is 0. M is 0. Because the way this really looks is, if I was going to y equals mx plus b, this is like y is less than 0x, and then the slope intercept, the intercept is 1, y-intercept is 1, so 0x plus 1. Well, the 0 times anything is 0, so you just don't need to write it. It's superfluous to write it. That's why they get y is less than 1. Okay, so the y-intercept there is the only number given, is the y-intercept, 1, 0, 1. So now we're going to play our game. We have a slope of 0. So here's the deal, guys. Let's take a look at what slopes of 0 look like. Let's just put this back to equals, go to OK, and clear this out. If my slope is 0 and I put in 1 or 2 or 3 or 4 or 8 or, I don't know, 15 or 32, and I graph it, what I'm going to get is a whole bunch of perfectly flat lines. And that makes sense because when we're looking at our protractor, I said a slope of 1 was like 45 degrees. A slope of 0 is flat, so there's no slope. Think about like the slope of a hill. There is no slope. It's flat. It's like Kansas, okay? It's flat land. So we're just drawing straight horizontal lines. Let's get rid of the calculator for a second and go back here and start plotting points. This is a lot easier than the previous problem because we don't have to actually work with rise over run. We're just looking for the y-intercept at positive 1. Okay, and now we need to know, do we draw a dashed line or a solid line? Well, here's the dealio. That's a less than symbol, so it's going to be a dotted line. Well, let's get to it. We have y is less than or equal to 1. Draw with a pencil. And what we're going to do here is mark, oops, I just made a mistake. We're going to mark our, I should say, we're going to mark our y-intercept with an open circle. So that's another thing. When you're doing less than or greater than with no equals part to it, you're going to do open circles and dotted lines. Open circles and dotted lines. So we're going to find our y-intercept, which is 1, and we're going to put an open circle there. All right, and then passing through that point, we're going to draw a perfectly straight dashed line. And, you know, to make this visible to the camera, I'll make it thicker, but you don't have to do this as thick. All right, so we have that dashed line there, perfectly flat. Now what do we shade? What do we shade in here? Well, it's less than, so less than means shade below the line. So what am I going to be doing here is shading everything below this line. And it's a dashed line. So I've got a dashed line and I'm shading everything below it. Okay. Okay. That is what we should get when we put this into the calculator. Let's see if it's what we get. Let's go back here. Let me clear out all those test points I plotted. And make sure you change your inequality sign to match your calculator. This is less than. Okay. And we're going to plot just y is less than 1. And we're going to graph it. Cool. So I've got a y-intercept of 1. Bingo. There it is. And the shading is below that line. It's perfectly flat. All right? So that's 19. Now let's go to 20. And when we're looking at number 20, we're back to our old sort of ways. We're going to have to do a little bit of work here. Y is less than 2x minus 2. So y is less than 2x minus 2. Is this in slope-intercept form, y equals mx plus b form? Yeah, it is. It is. We have a less than sign, so we know that we're going to be dealing with a dotted or dashed line. We're going to be dealing with open circles, open points. Now let's see, what is our slope? Well, our slope is 2, positive 2. So it's going to be steeper than 45 degrees. It's going to be steeper than that. So rise over run here. It's going to rise over run. When you have a slope of a whole number, it's like this 2 over 1. So up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. What is the y-intercept? Because that's where we have to start when we start plotting our point. Well, the y-intercept is negative 2. So we have a y-intercept of negative 2 and a slope of 2. So let's start plotting points. Take your pencil and put it at the y-intercept, negative 2. And draw, because this is a less than sign, we're going to be doing open circles. Draw an open circle at negative 2. Now let's start plotting points. We got a slope of 2. So it's a positive number. It's going to be a positive slope. We go up 2, rise, and then run 2 to the right. So up 2 over 2. Put a circle, open circle. Do it again. Up 2 over 2. Up 2 over 2. and we do it the same way going down. Down 2 over 2. Down 2 over 2. Looks like we got a pattern emerging here. If I put my straight edge on that, I see that I've got a straight line. Well, since this is a linear inequality, I'm glad to see that. Now, because it's less than, I'm going to put a dash. There's no equals here, so just putting a dashed line here. Oh, over here I should have made that a line. Okay, so I'm putting a dashed line here. So now I've got a dashed line, the slope of 2, and I realize I'm just making a mistake here. I'm making a mistake. I'm actually doing a slope. I said up 2 over 2, up 2 over 2. So those of you watching this at 1:51, I'm going to start fixing this problem. So I just, now that I'm looking at it, hey, let me explain how I just realized I made a stupid error. This is 45 degrees. That's a slope of 1. Uh-oh, I've graphed a slope of 1. That's not right. I even said that my rise was 2 and my run was 1, but then I started graphing up 2 over 2, up 2 over 2. I just got lost in thought, and I graphed a slope that was wrong. It was a slope of 1. Let me just erase that and try. Let's try that again, okay? All right, so let's go back to our, let's clear the deck, guys. Your teacher made a silly error. Let's go to our y-intercept of -2 and put that circle again. Okay. Now let's do this correctly. Let us plot our rise of 2 and our run of 1. So up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. Now we go back here. We can keep plotting. Down 2 over 1. Down 2 over 1. Okay, that looks much more promising. So now I've got a much steeper line. This is a really good teaching moment. First of all, guys, we make mistakes. And second of all, because we have this intuition about the slope, we caught it. So our slope that I messed up was a slope of 1. I was doing a rise of 2 and a run of 2, which is 2 over 2, that's 1. When I really meant for the slope to be 2, which is actually 2 over 1. So, paying attention to the details is what your teacher wasn't doing, but that's what you were doing, because all of you were probably pounding the screen saying, you're doing it wrong, you're doing it wrong. Good. That means you're getting good at math. I'm happy. So, here's the good news. We caught our error. We fixed it. All right. So, now I'm going to put a dashed line through these dots. So, dash, 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 plot twist, dash. Okay, so not a solid line, and then put your arrows to show that it's a line. Now, where are we going to shade? This is a less than symbol, so we're going to shade below the line. So let's get out our shading tool and shade below the line. Okay, that's what we should see when we put it into the calculator. A dashed line with shading below the line. and let's see if that's what we get. So we're doing less than again. So we already have our correct inequality symbol. And this time we're going to put in y is less than 2x minus 2. And we're going to graph that and see what we get. Yay! It looks like what we drew. That's good. That's very good. Okay, so that means that number 20 was correct. Perfect. So now on to number 21. Let's do number 21. We have y is less than 2/5 x plus 1. All right, so is it in slope-intercept form, mx plus b form? It is. What is the slope? Well, by now we should be fairly comfortable with the fact that the slope is right there, 2/5, 2 over 5. 2/5. What is this y-intercept of this inequality? It is positive 1. So put a 1 right there. Now, look at the inequality. It's already in mx plus b form, so we can just write this down. It's, again, less than. So in that case, we're looking for a dotted or dashed line and open circles. That's how we're going to graph this. So remember, when we're doing our slope, you know, m equals rise, ladies and gentlemen, over run. Rise over run. In this case, it's positive 2 over 5. So up 2 over 5. Or down 2, so up 2 and then 5 to the right, or starting at the y-intercept, down 2 and 5 to the left. Well, let's try not to make silly mistakes, Mr. Morelli. Let's just keep going. So let's start at the y-intercept, which is 1. Start there, put an open circle because this is a less than sign. Now we're going to go up 2 over 5. So up to 1, 2, 3, 4, 5. Put another open circle. Okay. Now let's go back to our y-intercept of 1 and go down 2 over 5. 2, 3, 4, 5. And put another open circle. So I was only able to fit 3 of those circles there. And I'm now going to put in a dashed line because this is a less than sign. There's my line, dashed line. Good. Okay, so now it's a less than sign. Is the shading above the line or below the line? Well, by now you should be saying it's below the line, man. So yeah, let's go ahead and shade in below the line. Okay, so that's what we're looking for, and let's check if we were correct. Let's go to y, and we got the less than symbol, clear that out, and put in 2/5, so open parentheses, 2 divided by 5, close parentheses, x plus 1, graph. All right. Cool. So again, we have a graph that matches all of our intuitions, and we did it by hand, and then the graph did it. What's our y-intercept? Y-intercept is 1. Fantastic. And then finally, we have, this is going to be interesting, because on number 22, it's almost the same with some very key differences. So on number 22, what is my slope? Well, first of all, is this in slope-intercept form? Yeah, it is. Y is greater than or equal to negative 2/5 x plus 1. Aha. So the slope is negative 2/5. What is the y-intercept? The y-intercept is 1. Okay, positive 1. So let's look at this negative 2/5 slope. So m equals rise over run, and our slope is negative 2/5. So that means that it's negative 2 over 5. So now here's how here's how we're going to have to plot this thing. And we have a greater than or equal to sign, so we're looking for a solid line with solid dots. So here's how we're going to plot this thing. Let's think about this for just a second. It's going to be a downward sloping line instead of an upward sloping line. We're going to start at the y-intercept of 1, and we're going to put a solid dot there to indicate the y-intercept. Now what do we do? Well, instead of going up 2 over 5 like we did here, we're going to go down 2 over 5. Okay, so in this problem we had a slope of 2/5, so we went up 2 over 5, up 2 over 5. Here we're going to go down 2 and then to the right 5. So this is our next point. And then this is all like reversed from the way we've been doing it. Now, if I want to plot another point over here, I'm going to go up 2 and then to the left 5. Right there. So again, rise over run. I'm going to go down 2 over 5. And here, if I'm going to have to backpedal, I have to do everything in reverse. I have to go, if I'm going to go up 2, now I've got to go to the left 5 to maintain that downward angle. The key point is to remember you're going to end up with a negative slope. So if you get confused, just remember your line needs to end up doing one of these down angle things. So now that I've plotted those points, I can put my straight edge to it and draw a solid line because it's greater than or equal to. Draw a solid line. And we will put arrows on that guy. Now, question. This is greater than or equal to, so are we shading above the line or are we shading below the line? Well, greater than or equal to, we're shading above the line. We're shading above the line. Like that. Well, is that what the calculator thinks? I don't know. Let's check it. Y, and then I got to change my inequality symbol to greater than or equal to. And I'm starting to feel like maybe let's put it in red. Okay? So go OK, clear this guy out here, and put in open parentheses, the glare, open parentheses, negative 2 divided by 5, close parentheses, plus 1. Right? Graph. Uh-oh, something is wrong. Go back to y equals. It's greater than or equal to. And I have minus, oh, I didn't put the x value. Minus 2/5 x. Minus 2/5 x plus 1. Okay? That's what it needs to look like. Y is greater than or equal to minus or negative 2/5 x plus 1. Now graph that. Fantastic. We have another graph that matches our prediction. So far, so good. Let's flip the page. All right, yay, only 3 more. And then some bonus points. Okay, y is greater than or rather 2/5 x. Okay, so on this one, the slope equals 2/5. What's the y-intercept here? Remember, there was no b value, so b, or the y-intercept, is 0. Remember that from earlier. That means we're going to be passing through the origin. So I know I'm going to have a point at 0, 0, but is it going to be an open circle or a closed circle? Well, this is a greater than symbol, so I'm going to be doing dotted or dashed lines and open circles. So to get things started, I will plot the point at the y-intercept. That is right at 0, 0. I'm going to put a point here. Well, what is my slope? My slope is 2/5. Well, remember, rise over run. That means, in this case, up 2 over 5. Up 2 over 5 to the right. So I'm going to plot a first point. Will be starting at the y-intercept. I'll go up 2 over 5. And I will plot a point. And I'll leave that open circle. Then I'll go back to the y-intercept, and I'm going to go down 2 and to the left 5. Down 2 and to the left 5, just kind of reversing that slope. I know I'm going to have a positive slope because the trend is up here. And now I'm going to put in a dashed line because this is a greater than symbol. If it's a greater than symbol, am I going to shade above or below the line? I'm going to be shading above the line. So I'm looking for my calculator to confirm that this is what the graph looks like. Okay, let's see if our calculator does in fact confirm that. Let's see, make it look exactly like what the calculator will show. Okay, let's get the calculator out and change our sign to greater than. We'll go with magenta this time, and I'll cancel out what I had in there earlier and put open parentheses 2/5 close parentheses x, and I will plot. Bingo. Okay. Do I have it passing through the origin? Yeah, y equals 0, x equals 0. Perfect. So that was correct. And now we will do number 24. 24, y is greater than or equal to 1/2 x plus 3. Is this in y slope-intercept form, y equals mx plus b? Yeah, it is. So in this case, my slope, m, equals 1/2. Okay? How about the y-intercept? Well, the y-intercept is 3. So b equals 3. What do I do? Well, in order to plot these points, I first need to ask, is it going to be a dotted line in an open circle or a solid line in a closed circle? Well, this symbol is greater than or equal to. So I have a solid line and a closed circle. That's what I know. So now, how do I start plotting this point again? These points. I start at the y-intercept. So I start at 0, 3, and because it's greater than or equal to, I'm going to put a closed circle there at 0, 3. Closed circle. Now, the slope is 1/2. So rise over run. Let's try not to make the same mistake I made earlier. This time it's 1 over 2. So rise 1, run 2. Up 1 over 2. Up 1 over 2. So I'm going to go up 1 over 2 and close this point. Up 1 over 2, close this point. Up 1 over 2, close this point. Now let me go back to my y-intercept and go down 1 over 2, close this point. And I'm just continuing this trend. Down 1 over 2, close this point. And finally, down 1 over 2, close this point. There you go. And it's good. We confirmed that this is going to be the same slope as the one we had in 23, so that's a good comparison. It's going to be a closed line, solid line, because it's greater than or equal to. So let me draw this in. Okay, that's going to be the line closed in. Now, it's greater than or equal to, so we're shading above the line or below the line? Well, we're shading above the line because it's greater than or equal to. So we're shading above the line like this. Really, the only difference between problems 23 and 24 is that in 24 we have a y-intercept of 3, where in 23 we had a y-intercept at 0. And then in 23, it's just greater than, so we have a dashed line with open circles. Where in 24, it's greater than or equal to, so we have a solid line with closed-in circles. So if I go back to my calculator, it's going to look pretty similar. But I'm going to change this sign to greater than or equal to. And we'll change the color to green. Okay. And it's 1/2 x plus 3. 1/2 x plus 3. Let me clear this out and put 1 divided by 2 x plus 3. Right? And let me graph that. And there we go. See? So these slopes look similar, you know, but we say, hey, I thought this slope was 2/5 and this slope is 1/2. Well, you know, those numbers aren't all that different, guys. If we go and just do 2 divided by 5, we get 0.4. And if we do 2.5 divided by 5, which would give us 1/2, we get 0.5. So they're pretty close. So you would expect those slopes to be similar. In fact, if we want to just, since we're close to the end, we'll play this game. Let's put this back on equals. And let's plot a slope. Let's plot both slopes by themselves. Let's plot 2/5 x here. And then here we'll put 1/2. So 1/2 x. And look how similar they are. Pretty similar. It's hard, really, without good resolution, to see the difference there. They're just slightly different. Okay? So anyway, let me clear that out. We only have one more to go. We're near the finish line. Can we feel it? Let's sprint to the finish line. Let's get through with a plum. Uh-oh. Number 25. Y is less than or equal to -5/4 x minus 1. Well, is this in slope-intercept form? Yes. So, what is m? What is the slope? Well, it's just -5/4. And what is the y-intercept, or b? b is -1. All right? So, remembering our rise over run game, we have a rise of -5. It's really like a fall, isn't it? And we have a run of 4. So we're going to fall 5, and then go to the right 4. Let's see how that looks. So we know we're going to end up with, because we have a negative slope, we're going to end up with a downward sloping line. All right, so let's start at our y-intercept of -1. And are we going to be doing a closed-in circle or an open circle? And are we going to be doing a dashed line or a solid line? Well, this is less than or equal to, so I'm going with a solid line and a closed-in circle. Okay? Let me start at -1, and I'll do a solid closed-in circle there. Now let me play my game. Down 5, down 1, down 2, down 3, down 4, down 5, and then over 4 to the right. 1, 2, 3, 4. Close-in circle right there. Go back to your y-intercept and just do what you did in reverse. Go up 5. 1, 2, 3, 4, 5. And then to the left 4. 1, 2, 3, 4. Okay. The check that you did this right will be that you could put a straight edge on it and connect the dots. Because it's less than or equal to, we're going to put a solid line. Sure enough, those points line up. That's great. Looks like the belt of Orion. All right, here we go. Okay, and we have a closed-in line. There's our line. Now, are we going to be shading above the line or below the line? Well, this is a less than or equal to symbol, so we are going to be shading, ladies and gentlemen, brothers and sisters, comrades and friends, fellow countrymen, workers of the world, below the line. Just like this. Okay, that's what we should get in the calculator. We got a negative slope. It's got a y-intercept of -1. It's less than or equal to, so we have a solid line with closed-in points, and we shaded below the line. Is that what the calculator tells us? Change our inequality symbol to less than or equal to, and let's make it orange to finish this whole problem set out with our panther color. Okay. And put in open parentheses -5 divided by 4 close parentheses x minus 1 and graph it. Okay, drum roll. Graph. Yay! We have a graph that looks like our curve, and if I hit trace, I see that my y-intercept is -1, which is good because it is here as well. Therefore, our graphs match on the calculator and on our paper. And we have finished the problem set. Now, these bonus points over here are questions. How difficult was this assignment? Do YouTube tutorials help me working the problems with, do YouTube tutorials with me working the problems help you? Well, that's a question to you. And then 3, how well do you understand f of x notation and how to solve functions? Where 1 is not at all, and 5 is I could teach it. So please do that. Each one of these that you do, you get 2 extra points. So, you know, for this assignment, there are a potential of 106 points on this assignment. Okay? So that was a long, long road with many a winding turn. Okay, as the song goes. So today we did 2 songs. We did Feelin' Groovy. Okay, slow down, you're moving too fast, and then it's a long, long road with many a winding turn. We did 2 songs today, and I mentioned that this last problem here looks like the belt of Orion. So those are your little trivial points for today. Thank you so much for joining us on another edition of Doing Algebra with a camera facing the table. I hope this was helpful to you. I hope that you now understand how to graph linear inequalities, that you understand how to do those interim solutions when you have to do a little bit of math to solve to get them in y equals mx plus b form, and that you know how to determine whether you're going to be shading above or below the line, how to graph them by starting at the y-intercept and then doing rise over run or fall over run, depending on how it works, and just developing that intuition that we looked at with the protractor. You know, so I hope this was a kind of succinct, helpful explanation of not only how to do this specific homework, but how to kind of do anything related to linear inequalities. You guys, if you go through this video a couple of times, you will be totally and completely set with linear inequalities. So thank you for watching, and have a pleasant day.